Yeah, good morning, friends. So today's session we will start with setting up the cluster. But if you directly come here and if you don't have prior knowledge about Hadoop, you will struggle to understand this. This is primarily after completing most of my development content, developer or big data engineer course content. People who have some understanding about Hadoop architecture, MapReduce architecture, Spark architecture, Hive, etc. I'm trying to show how to actually set up a cluster after doing the capacity planning in one shot. Otherwise, the better way is to start from scratch, then add one component at a time. First, we need to set up Ambari or Cloudera Manager, and then we need to understand HDFS is foundation, then MapReduce, then Hive, Pig, Scoop, etc. For each and every component, we need to understand the architecture, and then it's better to set up one component at a time uh, in the process of learning. But when it comes to implementation in production, you should not do one component at a time. You have to do both capacity planning uh, uh, by doing some analysis on the amount of storage you need, and also how much processing you will be doing on regular basis. Based on the two criteria, you have to determine the size of the cluster. And then depending upon the projects you want to roll in, you need to identify what all services that needs to be deployed. When I say services, all the tools in big data ecosystem like Hive, Pig, Scoop, Spark, etc. So you need to determine what all tools that needs to be deployed, and then you have to provision the servers, and then set up the tools like Ambari or Cloudera Manager, and then set up all the services in one shot. And for some of the services, you need to complete the prerequisites, and only then you should be able to add. So we'll go through the steps. We will start with capacity planning. We will start, then we will try to deploy most of the services in one shot. And as part of that process, we will first install the management tools along with the prerequisites, and then we'll get into the services. Okay. So for that, I actually created a spreadsheet in docs.google.com. I will try to share it after the class, after tomorrow's class. Okay. So these are the 1 minute. I have to add one more thing. Okay. So if you have to do it in a proper order, one component at a time, this is the order we need to follow. First, we need to create a couple of databases. Um, Both can be MySQL, no need of Postgres. So for now, I will be deleting this one. I will add it later. I am preparing this for other purpose also. That's why I have Postgres. Otherwise, Postgres is not required. You can choose either MySQL or Postgres, and you can use the same database for different purposes. And I will explain the purpose of the database as we move forward. And then we have to plan for management tool and then other things. So before getting into this, before adding the components, first thing we need to do is the capacity planning. Okay. So first, you need to consider the storage, and second one is processing. And also you need to factor in the SLAs to build the cluster. Let me get the tablet so that I can do whiteboarding wherever it is necessary. Just give me a moment. And also let me confirm that people in Hangout can see my screen. Yes, they are able to see the screen. So let me get my tablet. Okay. So first thing you need to uh, first thing you need to understand is the storage, and depending upon the amount of storage you need to have provision so much of means as per your planning you need to provision so much of storage, and storage, CPUs and memory are interrelated. Okay. So for example, uh, if you want to store petabytes of storage, just to use the Hadoop cluster as uh, uh, to store the data for compliance purposes. For example, your credit score. Okay, companies need to keep the data for 7 years. Will it be accessible on regular basis? No, it need not be accessible on regular basis. Typically, the recent data will be accessed frequently, but the 7 years worth of data needs to be stored for the compliance purposes, so that if someone raises the question, and the company can respond saying, based on this, we have create your score is determined, or whatever it is. It is the case with most of the compliance organizations, and the US standard period is 7 years. Even if someone has to be SOX compliant, they have to keep the data for 7 years. And also, if you are familiar with energy industry, there are something called ISOs, independent system operators, and they play the mediator role between the counterparties in the energy industry, the transmission companies, the generation companies, the distribution companies, and the households. Among all the stakeholders in the energy industry, these ISOs play a liaison role between all of them. All the transactions in the energy sector has to go through these ISOs. ISO stands for Independent System Operator. And if there is a litigation between the counterparties, they have to get the data out and provide the information to settle those litigations. Okay. So like that, there are many areas where data is stored for compliance purposes, but not accessed very frequently. So even though you have petabytes of storage required for those kind of stuff, but your processing need not be very high. Okay. That is called as 1 minute. Let me. I forgot the terms. That's why I'm opening a blog from Cloudera. No, not this one. Yeah, this is the one. No, not this. See, there should be somewhere. Just give me a moment. I'm not able to recollect the term. Yeah. So CPU intense or IO bound. These are the terms which you need to be familiar with. Okay. Which means that if it is CPU intensive task, um, y- uh, then you need to have more capacity to process the data than the storage. So the CPUs and memory are the major criteria. If your load is, let me zoom in a little bit. Let me. So these are CPU intensive tasks versus IO bound tasks, and the third one is balanced one. Okay, so if it is CPU intensive, wherein you have lesser data but do lot of regular processing on the data, then you should focus on more CPU and memory than storage. If it is as I mentioned to you, for compliance reasons, it is more of IO bound. You just have to store the data. You don't read quite often, and processing is done very less. In that case, you need to have more storage than the CPUs and memory. So this is the main criteria which you need to consider. You need to understand how much storage you require, and then how frequently data is being processed. For example, if you require 1 petabyte storage, okay, and at a point in time, on average, if you are trying to process 10 GB worth of data, okay, so to process 10 GB worth of data, it is enough at any point in time. It is enough to if our cluster is capable of running 100 tasks at a time. Okay, because our block size is 128 MB by default. To process 10 GB worth of data, you need 100 concurrent process at any or 100 concurrent tasks that should be running at any point in time. So if you have the capacity on your cluster to run 100 concurrent tasks all the time, then your cluster will be used effectively. Okay. You have to factor in the peak loads, not the average. You have to factor in the peak load. Whatever is the load at the peak, you have to plan your cluster for that. And then if you for the same thing, if you have 1 petabyte of storage, means if you want to store 1 petabyte of data, there is something called replication factor. Okay, and replication factor is by default 3. And if you want to store with replication factor 3, we have to consider average replication factor, because uh, uh, some of the data is more important than the other data. So some data you might store with replication factor 2, some data you might store with replication factor 3, some data you might want to store with replication factor 4. So what you have to do is, depending upon the overall data storage, and also you should be able to categorize how much data will be stored at what replication factor level, and you should be able to compute the average replication factor. Most of the cases it is 3 or 3.5. It will not be beyond that or less than 2.5. 2.5 to 3.5 is the range which we typically use. Mostly it will be 3 to 3.5. 2.5 is very rare. Okay, so let's assume our replication factor is 3. So we need to get 3 petabytes of storage. And when we try to buy the hardware, okay, we from processing perspective, we need to have 100 concurrent process at a time, because we are only trying to process 10 GB worth of data at any point in time. But from storage perspective, we need 3 petabytes because of the replication factor. And uh, you need to then do the market analysis if you have to buy the hardware, or if you already have the hardware, you need to identify which kind of servers you want to use. And typically, the servers will come as a unit which will have memory, CPU, and storage together. Sometimes we can add additional hard disks. We might be able to customize a little bit, but standard configurations are more than enough. So you need to identify proper standard configuration to tell the hardware team to get servers for you. Or if the servers are already available, you have to choose a proper configuration that is suitable to you, which can satisfy your both the criteria. Okay, from processing perspective, we need 100 cores. For example, if we have to run 100 concurrent tasks simultaneously, that means we need to have 100 cores, which means if each server have 16 cores, then approximately 8 to 10 nodes are more than enough from processing perspective. But if that server has only 32 terabyte of capacity, that means with 10 nodes, you will be getting only 320 terabytes of storage. Okay. If you want to add, if you are storing the petabytes of data for the compliance purposes, you just add more hard disks as much as possible. The server is capable of handling, and then you can add more servers. You will be over allocating from the processing perspective, but the storage will be covered. Okay. But if it is CPU intensive, sometimes you might have only 100 terabytes of data. But at a given point in time, you might want to process 1 terabyte of data, which means that 1 terabyte means 10,000 tasks at a given point in time. If you have to get 10,000 tasks at a given point in time on a 16 core or 32 core or 64 core machine, then you have to have, let's take the example of 64 cores, 10,000 by 64. I have to do equal in the beginning. So you need to have 156 servers. Okay. Automatically, the requirement of our cluster will exponentially grow if it is CPU intensive. Even though your storage is only 100 terabytes, which can fit in only, which means you just need to have 300 terabyte capacity, which will fit in 10 nodes. But as you want to process 1 terabyte of data at your peak on regular intervals, you have to simultaneously you have to plan for it. Okay. So this is more CPU intensive, this is more IO intensive. You are using your cluster to store more data and less processing. That is the first use case. Second use case is you have not so much big data, but the processing is quite high. So recommendation engines is the classic example where you have to churn enormous amounts of data or the complete set of data at regular intervals to come up with accurate recommendations. And then standard or normal load, standard or normal category. The third one is standard or normal, wherein you will just do a ballpark number and start with storage and just get corresponding ballpark number on the processing perspective, and then plan your cluster. And if it is required, you can either scale up or scale down in future. So these are the three standard ways of doing the capacity planning. Once the capacity planning is done, you will determine how many servers are required. In this case, it is 150. In this case, it is only 10. And then you will go to your hardware team and get your servers. Then you have to go to your system admins team who will set up operating system for you. Once the operating system is installed, they will give either root access or sudo to root access. Typically, it will be sudo to root access, and then people can start setting up the cluster. Now comes to this second tab, installation process. Okay, so here these are primarily for your worker nodes. Okay, we are not so the capacity planning will determine how many worker nodes you need, and then you will determine how, typically number of masters will not vary much. It can be anywhere between 3 to 8 or 9 nodes, and then rest of the stuff will be worker nodes. Okay, whether it is 100 node cluster or a 1000 node cluster, still you will be using only 7 to 8 worker nodes or utility nodes or gateway nodes. Altogether it will be 7 to 8, not more than that. Rest of the stuff will be the worker nodes only. Masters will be maximum up to 7 to 8. Okay, so first thing what you need to do is you need to set up MySQL database. The reason why you need MySQL database is we have to set up Ambari or Cloudera Manager, and how this Ambari or Cloudera Manager will work is, here I am trying to do the whiteboard. Oh my, yeah. So let's say you want to set up a cluster with for POC, you want to start with 10 nodes. Let me change the pencil here. So 10 node cluster, that means when I say 10 node, 10 worker nodes. Okay, so your cluster will be divided into primarily two categories. One is worker nodes, and then master nodes or utility nodes or gateway nodes, everything together. Okay, so in the master, so the master nodes are closely tied with your worker nodes. They are name node, secondary name node, and resource manager. Okay, name node, secondary name node or passive name node, and resource manager. So these three are masters for your Hadoop cluster. So to manage your cluster, there will be a lot of activity that will be happening on all these nodes in the cluster, and there are several others also, but I used the most important ones as part of the masters. You have other masters as well, like Hive server, Woozy server, and HBase region servers, Zookeeper, etc. Okay, but they are not that critical at this time when we try to understand the concepts. So I am not explaining from their perspective. The main thing is what you need to understand: you have bunch of worker nodes and bunch of masters, and there will be some activity happening on these nodes all the time. Okay, and you have tools like Ambari, Cloudera Manager. If it is Hotworks, it's Ambari. If it is Cloudera, it's Cloudera Manager. And also there are tools like Ganglia, Nagios, etc. These are open source monitoring tools. So to facilitate better operations, so these are primarily for operations purpose, which means on day to day, if there are any issues, you should be reported easily, and also you should have a web interface where you can monitor the cluster to see where the bottlenecks are. Okay, so these are the tools which you typically use: Ambari, Cloudera Manager, Ganglia, Nagios, etc. When it comes to Ambari and Cloudera Manager, the architecture is you need to have an agent. The corresponding agent of whatever tool you choose. If it is Ambari, it's Ambari agent. If it is Cloudera Manager, it is Cloudera agent. Has to be installed on all the nodes in the cluster. What they will do, they will keep on polling what is going on in the servers. Like they will be keep on polling the logs and see if there are any errors. They will be keep on running some commands such as top, memstat, iostat, networkstat, etc. Collect those information and pass that information to a centralized server, and that centralized server will facilitate you to monitor. That's what is happening when you log into CloudX Lab or Big Data Labs Ambari layer. Whatever data you are getting, or whatever reports you are getting, they are primarily based on the data pushed by all the agents that are running in the cluster to a centralized component called Ambari server if it is Hortonworks, Cloudera Manager if it is Cloudera. That the data which is pushed by agents has to be stored somewhere so that it can be reported. For that reason, you need a MySQL database or a Postgres database, whatever database is supported by the corresponding vendor. So there is a question here. So Ambari or Cloudera Manager has to, so there is a server component and there are agents. So please ask the questions to everyone rather than sending it to me only, so that even if I do not read out the question, people will have context. Anyway, Ambari, and the question from Venkat is, Ambari and Cloudera Manager has to install on data nodes or master nodes? The answer is none of those. Okay, there is a agent component and there is a server component. If you are asking from the server component, you should not install the server on any of these master or worker nodes in a production environment. If it is agent needs to be running on all the nodes. So here in this case, all these nodes will have a Ambari agent or Cloudera agent. Okay, but the centralized server which will collect this data, agents will be pushing the data to the centralized server. The centralized server should be an additional component as part of the masters. Sorry. Anyway, let me erase this and use different color so that people can understand easily. So this will be, you can consider it as a utility node and you can categorize as part of the master itself. Here you will have the Ambari server or Cloudera Manager, which is a centralized server, and all the agents will push those regular stats and the logs to this server, and then server will agents that are running on all the nodes will start pushing that information at very regular intervals, and server will actually churn the data. If it is an abnormal event and if it has to be alerted, then the server will take care of sending the alert to the operations team. Otherwise, it will just store the data for the reporting purposes. So the people does not focus on these things that much. But if you log into the CloudX Lab or the Big Data Labs Ambari UI, you see bunch of reports on the right side. On the left side, you see services, and on right side, you see bunch of reports. So people can monitor and click on this one of these report and see how it is performing. They can actually change this to different time interval and see how the CPU is performing. By this, I can understand how whether people are using my cluster or not. From lab perspective, that is a very important information for me. But in a true production environment, people can actually see if there are any spikes at a point in time, and if some people are reporting their jobs are running slow on a regular basis around the same time, you need to identify the reason for those spikes and determine if you have to add the cluster. So these reports are very, very important, and all these reports are actually provided you by the centralized server, this one. And to provide those reports, that information has to be stored somewhere. That's where MySQL comes into picture, or MySQL or relational database comes into picture. Okay, so that's why we have to set up the MySQL first and have the MySQL or relational, any relational database that is supported by the corresponding vendor, and then you have to start with the rest of the stuff. Once you set up the environment, you have to create the database. If you have to run any scripts to create the tables and all, you have to take care of all those things. So in this case, I already set up MySQL. Okay, and also, even if you don't have a MySQL database, this Ambari server as well as Cloudera Manager comes with an embedded database also. But in production environments, we typically don't use embedded databases. We have to use database as per our standard. And we have to build the database external to the cluster so that the data is backed up on regular intervals. Even if cluster goes down for some time, you still have the database. And also, if something goes wrong on the database, it should not impact your cluster. For that reason, database has to be separated from the cluster and should be maintained as per the enterprise standards. You should not maintain as per the Cloudera or Hortonworks or standards, and you should never use embedded databases. Embedded databases are primarily given to you to simplify the POCs to begin with, to kickstart, to determine whether your requirements can be served by this big data technologies. But when you actually plan for the production, you have to externalize the database and you have to choose the database and the strategy around your database as per the enterprise standards. I will come back to that question. Let me log in here. You will see that I will demonstrate and then you will understand. One more question from Jiva. Could you repeat how Ambari or Cloudera Manager server runs agent in several level, server level or worker nodes? You will see that. I will demonstrate what happens. Okay. So first we have to set up the MySQL database. And if you run show databases, by default, Ambari comes with Postgres, but I have externalized it and I have created a separate database. 1 minute. I think database is gone. No, it shouldn't. It shouldn't go away. Okay, I'm in a wrong server. Sorry. Okay, now I am logging in. Show databases. So this is the one which I have created. Database name is Ambari, and I have Ambari_user also as a username. And when we actually, after setting up MySQL database, if we do advanced setup, Ambari, I will not be demonstrating how to install Ambari and how to set up. I will not be able to do it within 3 hours. For that reason, some things are already taken care, such as this one. I have already created a MySQL database. And if I go to this MySQL database and run show tables, you will see list of tables which will actually store all the necessary information to get information, to store the information retrieved from the agents into a database, and reports are provided to you based on that. Okay, so this is the relevance of the MySQL database. So first you have to set up the MySQL database, and the second step what you have to do is you have to set up something called local yum repository. Okay, I will not be going into too many details here. If you really need to understand how to set up the local yum repository, I have videos on my channel. You can go through it, and it is not required actually. You don't need to understand in detail. Just go through the video and understand how it is done. Otherwise, also for POCs, what you can do, if you have internet access on all the nodes in the cluster, you just download something called repo files. So let me explain you. So if you go to this location, if it is CentOS, this is the location you need to go, etc m.repos.d. If you go to this location, I copied some files such as ambari.repo. I don't know why I skipped it, but let me show you. Okay, I have ambari.repo and I have hdp.repo and hdputils.repo. So if you look into these files, cat ambari.repo, okay, so here you have base URL. So base URL will have all the installables. So in Linux world, especially the Red Hat Linux world, the installables will have .rpm extension. Okay, RPM stands for Red Hat Package Manager or something. So all the files which have .rpm are installables. So those are maintained in something called repositories. So you see different categories in repos. These all files have CentOS as prefix. So this is a CentOS standard repository. And as part of the OS installation, you will get all these things out of the box, these CentOS repositories. And then to install any third-party product, if it is supported on that operating system, the third-party vendor will provide this repo file, and that repo file will point to their repository for the installation. But if you have 100 nodes in a cluster, and if all 100 nodes try to connect to the public repository and download over the internet, it will clog your or your enterprise network will get a lot of contention, and it might impact the other areas. So it is not the good practice to connect all the servers at the time of installation to the centralized repository and download it to the public repository and download it over internet. It's not a good practice. So what we have to do, we have to do something called local M repository setup. Okay, for that you need to set up HTTP server, and then you have to download only onto one node connecting to the internet, and then you have to tell all the other nodes to use local M repository server for the binaries. In this case, if you see, the URL is my URL. It's not a public URL like this. This is just a key. So even if you don't change it, it's fine. But this is the one which will have the actual repositories. For to get those repositories for HTTP, you have to set up HTTPD server first, or Nginx server, and then you have to execute certain steps. And your system admins will be glad to help you. You just have to tell them that we need to set up local M repository for our POC. So please help us, and they will be glad to help you, or you have to step up at the time, explore the steps required to set up local M repository server, and then use the local M repository server while setting up. So far we have created a database, and I have spoken the relevance of creating the local M repository server. Once the local M repository server is set up successfully, you can run this command called mrepo_list, and it should not throw any error, and it should give details about these three. If it is Ambari, you have to have update Ambari, you have to have HDP and HDP utils. These three are the repositories which you need to set up properly before starting the installation process. Once that is done, you can say -y install, and this is only for Red Hat flavor Linuxes. It could be Fedora Linux, it could be CentOS, or it could be Red Hat. In production environment, people typically use CentOS or Red Hat. They don't use Fedora, even though it's a Red Hat flavor. And some of the companies use Ubuntu. Companies in UK typically use SUSE Linux. So you need to understand, for the same steps, you need to understand what is the counterparts, or what is the other commands of the underlying operating system if you decide to go with other operating system than Red Hat flavors, such as Ubuntu or SUSE Linux. Okay, only commands will change. If it is Ubuntu, the command is apt-get, and the repository location is different, and the file naming convention for your repository configuration files will be different in Ubuntu. So you need to understand those differences, and you have to follow those steps of Ubuntu or SUSE, whatever operating system you choose. But mostly 70 to 80% of the scenarios, they'll be using Red Hat. So whatever I am explaining are apt for all the 70% or 80% scenarios. Type of the OS, you can start with uname -r, I guess, or uname -a. Okay, it might not give the actual OS version. If it is CentOS flavor, you have to cat on etc release. I think etc Red Hat release. Yeah. If it is Red Hat flavors, if you run etc Red Hat cat on etc Red Hat release, this is a configuration file, and this will have information. We are trying to read the contents of it by using cat. Cat is not a command to get the operating system. Just we are trying to read the content of this file to understand what is the actual operating system that is running. So in this case, I am using CentOS Linux release. This command will not work with Ubuntu. You need to understand the relevant command for Ubuntu to understand which version you are using. You can start with uname -a. If it is Red Hat basis, you can run this additional command to actually get a proper release name. Okay, most of the times you will get the actual OS information directly here. In this case, this kernel is modified by OVH. So this is OVH based version. That's why it is not giving any CentOS or Red Hat related information. But typically, you will get it over here itself. If it is Red Hat flavor, you have to run this additional command. If it is Ubuntu, I'm not sure. You have to explore that. Okay. So now, once it is set up, if it is CentOS flavor, you have to say yum-y install Ambari server. Okay. Then it will actually connect to the repository. In this case, our repository is this one for Ambari, and it will download all the RPMs and it will install. Okay, already it is downloaded. It will cache and it will install, and it will clean up the cache. Once the Ambari server is installed, what you have to do is you have to say Ambari server setup. Okay, when you run this command, let me try setting up again. Okay, so here it is saying, so installation is already done. As part of the installation, it will actually download Ambari, it will install RPMs, and also it will download the embedded database, which is Postgres database, and it will install on your machine. Okay, but at the time of setup, you have to tell which database to connect. So in this case, SE Linux status is disabled. If it is not disabled, you have to disable, or you have to do some additional steps, and then customize the user account for Ambari server. I don't want to customize the user account. Sometimes you want to use, people might want to use non-root user. In that case, you have to change these things. If you are fine running as root, you can leave it at the end, which is default. And then it will download JDK because JDK is required. And I don't want to change the JDK, so I am using the default one. And I want to get into advanced database configuration because I don't want to use the embedded Postgres database. Instead, I want to use MySQL. If it is Oracle, you have to choose 2 here. As I'm trying to use MySQL, I'm choosing 3 here. Okay, it is already selected. You can see the default here. Okay, and hit enter. So host name is, I have on this only, gw01.itversity.com. So before going to further steps, make sure you are able to connect to the database using the information which it is asking. Okay, so here I am again connecting using another session so that I can validate. And MySQL -u, I think the username is Ambari user, which I have created already. Host is gw01.itversity.com and password to prompt for the password. So it is not correct. Let me do this. Okay, so use information schema and show tables. Select star or describe user privileges. Yeah, so it's somebody underscore user only. Then why it is not working? Let me remove this probably. Is working. Then why Umber user is not working? I have used the standard password only and I have tested it earlier also. Okay. Let me drop the user and recreate it. That's why it is very important to validate. Create user, sorry, drop user, Ambari underscore user, create user, Ambari underscore user, identified by. For now, I am using simple password. Okay, actually, I'm running on wrong server. Shoot, my lab will be impacted. I will fix it later. Okay, so I'm running in wrong server. That's why it is problematic. I have to use HTTP 00 only. Yeah, this is the one which I'm supposed to connect. Okay, I have to stop this one. I got lost, sorry. Okay, this is the one. I should have used this one, but I used the wrong one earlier. Anyway, that's fine. I will fix the lab later. Now my actual lab will get impacted, but after the class, immediately I will fix it. So this is the one which I'm trying to demonstrate you. Okay, so here I have to kill this session, and first let me run Ambari server status. It is running, and if you go to this etc m dot repos dot d and cat ambari dot repo, and you can see here it is using a different URL which is local to this machine. So local repository is set up, and then Ambari server stop. So I stopped the Ambari server. Now let me go to the MySQL and make sure we have the database for our advanced setup. Okay, MySQL -u root -p. Okay, and here if you say show databases, you will not see the database for Ambari because earlier I didn't set up using advanced setup. Instead, I use embedded database. That's why we didn't see the Ambari database here. Okay, so now we will create a database. Create database Ambari, and then create user Ambari user identified by ITversity, and then grant all on Ambari.star to Ambari user plus privileges. So your database is ready and the user is ready. Okay, now you can exit and then say Ambari server reset, because whatever I have, I just want to delete it. Okay, now the server is reset, and then we have to say Ambari server setup. Okay, here we don't want to customize, we want to run it as root only. So no, I don't want to customize JDK. Here I want to use advanced database configuration, and then I want to choose MySQL, which is 3 here because the default is Postgres. I want to use the database running on the local host. If we want to point to other database, we can actually give the host name of it. In this case, hdp00itversity.com is same as localhost. So either of them will work. I'm using hdp00itversity.com. Then the port number, depending upon the database, you have to give the port number here. MySQL, the default is 3306. You have to talk to system admins and get the actual port number. In this case, it's default, so we will be leaving like that. Database name is Ambari. Username is Ambari user. And password, I have given ITversity. Okay. Now you have to run this script. What it will do, it will create all the tables that are required, whatever I have shown earlier on other server, that those tables are created because of this script. So first we need to run that script, and then we have to enter here. So I'm connecting to others, connecting to the same server using another session. So here I have to connect to the MySQL database using user Ambari host, and password. Ambari underscore user is the username, not Ambari. So here I have to say Ambari underscore user. Okay, and then password ITversity. Use retail underscore DB. not use Ambari. Ambari is the database name. Okay, and then source, give that script and hit enter. Now it has created the database for you. You can run show tables command and your database is ready. Okay, now you can say yes, and then it will complete the setup and it will set up Ambari server for you. Once it is done, you have to start by running Ambari server start command. So now so far we have only covered how to set up the server. We haven't set up anything yet. Even we will not be we will get the servers, and there shouldn't be any binaries on any of the machine on any of the servers yet. We only designate what is a name node, what is secondary name node, what is resource manager, and we will tell what are worker nodes. We will designate. We will not have anything on them. We will get IP addresses and networking established between them using passwordless login using SSH. And then first thing what we will do is we will set up the Ambari server the way I have shown. Now we will start the Ambari server. We have started the Ambari server. We have to make sure Ambari server comes up on reboots. So there is a command called check config here. Check config Ambari server on. Okay. Then once the Ambari server is up, if the Ambari server is accessible to you, you have to go to the browser and give the IP address and port number. Okay. And it will take you to the screen. Default username is admin and password is also admin. You can change it once you log in. Now you got the wizard. So because we haven't set up anything yet on the cluster, it will first start with the wizard. Okay. Then you can click on launch install wizard. By this time, you should have all the servers provisioned with operating system. Nothing else on top of it. No Hadoop components, nothing. First thing what we will do is we will set up the database as per this order. And then we will set up the management tool, that to server component of it. Okay. And here you can give the name to the cluster. Let me name it as HTTP. Click on next. So here these are the components which will be downloaded or installed. This is just informational purposes. And here if you want to use the local repository, you should choose this one. And our operating system is let me see the operating system here. Uname -a and then cat etc release etc red hat release. It's actually 6.8. So here I have to go to, I should remove the Debian or whatever. You can leave them also, but it's better to remove and have only the Red Hat 6. And then we have to use the base URL for both Ambari as well as HDP. Okay. To get the base URLs, you have to go to the repo files, etc m.repos.d, cd, ls-ltr, and then you can cat Ambari. Ambari is already done. Here we are talking about HDP. So this is the path which you need to give, the base URL which is specified in this file. And this is taken care by me. Originally, when we download the repo files, it will be pointing to the public repositories. But once the local repositories are created, you need to get the base URL based out of local repository. And then at hdp-utils.repo, take this base URL and paste it. Okay, now you can click on next. So this will take care of HDP and HDP utils, but we need to set up Ambari agent also. Okay, and Ambari agent is part of Ambari repositories. They are not part of HDP or HDP utils. So what we have to do is we have to copy this Ambari repo onto all the nodes in the cluster. In the back end, when we actually go through the setup process, it will connect to this local Ambari repository and install Ambari agent at that point. Till now, if we are on plain slate, we will not have Ambari agent on any of the server. We only set up Ambari server first, and when we go to this step and when we give the credentials to log into the cluster and set up the components, then it will connect to the Ambari repository to install Ambari agent, and then it will set up the other components. Okay, so if I go to the other host here, etcm.repos.d ambari.repo, you can see that it is pointing to local centralized repository, and from here it will download and install Ambari agent on all the nodes in the cluster. As of now, Ambari agent is already installed in this environment. Otherwise, you will not have. Okay, even though I reset it, you will still see the remnants of my previous installation. But on a plain slate, if you just start, you will not have anything on those machines. Okay, so far only this one is done. Now we are going to set up rest of the components, starting from Ambari agents to name nodes, secondary name nodes, resource manager. All the necessary softwares will be installed on every node. So we are only talking about installation. We are not talking about configuration. Then comes the configuration part, which we will see. Okay, so to give to go to the installation, you have to give the host names. So this is a 5-node cluster which I am trying to set up. The first node name is http://itversity.com. We have to add this. Even though Ambari server is installed, still we have to install Ambari agent on this node as well. So we have to start with that, and then either you can use patterns. You can see the patterns here, and you can enter all the IP addresses or public DNSs for each of the host on which we are trying to set up. So you can click on these patterns to see how you can actually pass. Okay, it's only giving tooltip. Oh my god, I don't know how to. Okay, I just have to keep it like this. You can see you can use pattern expressions to specify number of target hosts. For example, to specify host 01 dot domain through host 10 dot domain, you can say host 01 - 10. So in this case, if I want to set up 00204, I can say host 00204 instead of typing one host after the other. Okay, if you are trying to set up on hundreds of nodes, this will save significant amount of time. And then you have to pass the private key. For that, you have to set up SSH on each and every node in the cluster with common key across all of them. You have to copy paste that one. Cat .ssh id underscore RSA. We can copy this one. You should not show these things to everyone. In this case, it's just a lab for me, so I am showing. But in production environment, you should not show these keys to anyone. You have to be extremely careful when you are trying to do in your work environment. You should not share the screen and show to others if you need help from others. Okay, and register and confirm. Now the IP addresses are resolved automatically from 00 to 4. Click on OK, and then it will start the installation process. You can click on this to understand what is going on at any point in time. It will take some time to actually start the installation process. Once you actually see a particular component being installed, you can click on that and you can see the process progress. You can see it here. So it is very important to go through these things so that you understand the order. So you can see here the first thing what it is doing is it is doing some copy stuff, and actual installation started here. And first thing what it is installing is setup agent, okay, which is nothing but Ambari agent. And then it is registering with the server, which is already installed. Like that, on each and every node, you will see the progress. First thing it will do is Ambari agent. Okay, and installation is already, it will take some time. In my case, it is done because I have already installed the software on this and then reset the Ambari server. That's why it is pretty fast. Otherwise, it will take few minutes. You have to click on this and see all the warnings. So here, because I ran earlier, it is showing some things are available, and if you want to clean up, you can run these things. I can ignore these things in some of the cases I cannot ignore. I will try to ignore for now, but you should not ignore in the production environment. You have to take all the necessary actions and make sure that everything is positive, or you need to have proper explanation to before proceeding further. And then click on next, click on OK. So installation part is done. Now we are talking about the configuration part, configuration and deployment part. Okay, so these are the services which are available. And as I have explained earlier, once you are done with capacity planning about storage and processing at any point in time, then you need to determine what all services you need to have. You should not set up all the components that are available. For example, in most of the Hadoop installations, we don't need HBase. If you don't need the HBase, that planning needs to be done prior itself. And then when you come to this point, you have to deselect all those tools that are not required. Okay, so I don't. Let's say I don't want to install HBase, Falcon, Storm, Accumulo, Kafka, Atlas, Knox, SmartSense, Zeppelin, and Slider. Okay, and out of these services, there could be some dependent services. For example, Zookeeper. You don't use Zookeeper as a developer on regular basis, but most of the components are dependent on Zookeeper. So you have to choose those parent services, even though you don't interact with them directly. There are very few of them. One is Zookeeper, and I think you will encounter an issue if you are not selecting any dependent service. For example, here it is saying that you did not select Slider, but it is needed by other services you selected. We will automatically add Slider. Is this okay? You can click on OK. And then Slider is also selected here, and then proceed anyway. Okay. So now comes the relevance of the spreadsheet again. You have to do this before starting the process. You have to tell, you need to understand the architecture of all the components which we are trying to install. And we have to tell which one is the master, which one is the worker node. Okay. In this case, I want to set up only one node as master. Okay. So for all the masters, I will use the same IP. And if it is required, if a particular service have some worker components, I will say A. If it is not, if a particular component does not require anything on worker nodes, I will say NA, not applicable. A for applicable and NA for not applicable. So we need to fill this before actually start the setup process. But I am doing now because you can closely relate to it. But as per your process, if you have to set up the cluster, first you need to fill this. You need to identify the number of servers. You need to determine the number of masters that needs to be set up, and then you have to assign the roles for the masters. So Zookeeper, the architecture of Zookeeper is, it needs to be, it's primarily for load balancing and failover, and it needs to be running on 3 nodes. Okay, in this case we have only one master, so I am only giving HDP 00 for all the 3. But in production, you need to have 3 different masters. So let's go to Zookeeper here. And as we are only setting up on one node, we have to delete these two. Okay, but if you have multiple nodes to designate as masters, you need to make sure that Zookeeper is running on the servers which you want to run. Because the automatic selection might not be in line with your planning. Okay, so you have to make those corrections before going to the next step. So this step is called the configuration step. Installation is already done. Now we are trying to configure uh, first the masters, and then we will configure slaves and clients. That's where the worker node configurations will come. And then if we have to customize some services by providing some credentials, etc., we will do it as part of the customized services. Okay, so now again we'll go back to this. So the next one is HDFS, and you have to do it in this order only, because Zookeeper is the foundation for load balancing and failover, and then HDFS is the first component which you need to consider before anything else. Without HDFS, which is file system, you cannot do anything on the cluster. So when it comes to HDFS, typically we'll have two masters. One is name node and second one is secondary name node. If you do high availability, you say active and passive configuration. If it is typical configuration, you say it as name node and secondary name node. Okay, so here I would like to use HDP 00 for name node, and also HDP 00 for secondary name node. Ideally, in production environment, they has to be separated. They has to be set up on two different nodes. But here, as we have only one master, we are choosing the same master for both name node and secondary name node. And here, name node is selected properly, but secondary name node is chosen the wrong one, which is not as per our plan. So we have to change it. And then comes Yarn. Yarn have something called resource manager, and I want to designate a third node in the masters to be for Yarn. So in true production scenario, we should not set up Yarn master on the nodes where name node and secondary name node is running. On the masters where name node, secondary name node is running, no other process should be running except for Zookeeper. Zookeeper is a very lightweight process, and it's primarily used for load balancing and failover. Hence, you can set up Zookeeper on it, but no other component should be running, because if there is a bug in the traditional component, and if it brings down the server because of that bug, your entire cluster will be impacted. So it's your HDFS masters and Yarn masters are the most sensitive ones, and you have to make them immune from any other side effects, of the other components. So in this case, I would like to set up resource manager, which is the master for Yarn. I hope you could recollect or relate to the resource manager term, which is nothing but master for Yarn. And then MapReduce 2 requires an additional component called okay, and we have to consider worker nodes here. On all the worker nodes, it is applicable, and we have to set up something called data nodes for HDFS. For Zookeeper, it's not applicable, so we don't need to set up anything for Zookeeper. For Yarn, we need to set up something called node managers. So masters will have resource manager, and worker nodes will have node managers. Okay. And for MapReduce, you don't need to set up anything for worker nodes, but for masters, you need to set up something called timeline server. And that timeline server, if you have more than 3 masters, can be on a different node completely than where your resource manager is. If it is only 3 masters, for whatever reason for your POC, you can set up on the same node where your resource manager is running. Okay, because Yarn and MapReduce are tightly related. You can actually club those two when there is a contention for resources. But if you have a very large cluster, and if you have 8 or 9 masters, you can have MapReduce to job history server on a different node. Okay, so in this case, I would like to set up on the same node as resource manager. It is called as job history. And on with Yarn also, on top of resource manager, there is also called app timeline server. So you need to recollect all the architectural components, or you have to review the architecture and need to determine what all components needs to be set up even before we start setup process. Okay, so here app timeline server. So this also has to be set up. So before going further, let's configure the Yarn and MapReduce to here. So first Yarn, we have to go to the resource manager. As HDP00 is master for everything, I am choosing HDP00 itself as resource manager. And app timeline server also should be on HDP00. History server is also on HDP00. Okay. If we designate HDP00 as master, in our case, if we consider some other thing, we have to change accordingly. Okay. So like that, we have to go through each and every component. And the next thing is Hive. We will not, we don't need to plan for HBase at this time. We will plan for others. We will not do NiFi, Flume, Kafka. We will only do these things for now. Okay. Now comes Hive architecture. Before going to Hive, let's get into Scoop and Pig. I have taught you Scoop. Scoop is something called client-only tool. You don't need to have any components on anything. Okay, so you don't need to set up anything with respect to Scoop. Same is the case with Pig. So there is nothing to be set up because it uses HDFS for storage and MapReduce to process. So you don't need to set up anything for Scoop and Pig except the gateway. Okay, we will see that later. And then Hive. When it comes to Hive, Hive also uses HDFS for storage and MapReduce for HDFS for storage and Yarn plus MapReduce to process the data. But it has an additional component called Hive server and Hive metastore to facilitate you to store the metadata in MySQL database, and also to facilitate you to access the Hive database over JDBC. Hive requires two components. One is Hive metastore and second one is Hive server. So we need to set up those two things. So here, typically we will not touch these two boxes. Resource manager is less sensitive compared to HDFS. It is very important, but it is less sensitive compared to HDFS components. Even in HDFS components, name node is more sensitive than secondary name node. Hence, to just load balance between the other two masters, don't touch the node which is designated as name node. But if you want to load balance the other components between the other two masters, you can set up Hive metastore and Hive server on this, or you can even set up on the Yarn master tree itself. It all depends upon where you want to set up. Again, if HDFS is set up for active passive configuration, any of these two nodes can be active any point in time. So from that perspective, it might be better to set up Hive metastore and Hive server on master 03. And to store the metadata, we need to have a MySQL database. So first we need to set up MySQL database for it. And then we have to set up, in this case on HDP00, we want to set up Hive server and Hive metastore. Everything is going on Hive 00 itself. So here you can go, and for Hive, you can say, I want to set up Hive server on HDP00 and Hive metastore also on HDP00. For now, you don't need to worry about MySQL database. As part of the customized services, it will prompt you where it will prompt you to choose the location of your database, and we will choose at that time. Okay. So for now, we have told the wizard that Hive Metastore and Hive server has to be set up on HTTP 00. Okay, and then the next component, which is Spark. Okay, for Spark, we use Yarn in our environment, hence we will not have any additional component. For storage, we use HDFS, so nothing is required on this and on this. But here, again, Spark have something called job history server. So to get the history of MapReduce jobs, you use MapReduce job history server. To get the history of Spark jobs, you have to use something called Spark job history server, and that also will be set up on HTTP 00. So Spark job history server. On slaves, you don't need to set up anything because we'll be using Yarn to process the data. If you are not using Yarn, if you are using Spark Mesos, then you have to plan for additional configurations on the worker nodes. In this case, we are simplifying it by using Yarn itself. And then the final component, we determine all the servers needs to be set up, and we are planning for it. And the final component is Woozy. Woozy also nothing needs to be set up on these two, but on the third one, probably we might have to set up something called Woozy server, because Woozy also have to have a centralized server, even though it uses MapReduce to submit the workflows. Still, it requires Woozy server. You have seen in the last class, and you don't need anything on the worker nodes. Now we go back here and choose HTTP 00 as Woozy server, and then metrics collector. In this, the metrics collector Grafana Spark history is already HTTP 00. Grafana and metrics collector are related to Ambari, and we want to have those things as part of HTTP 00 itself. So metrics collector is the one which will collect the information from the agents and store in the underlying database, and Grafana is another process which will complement the Ambari management tool. Okay, so we just choose HTTP 00 for those two things and click on next. Okay, now we have configured masters. We have already configured masters. Now it is asking us to configure slaves and clients. Both the things it is trying to ask us to configure. So automatically it has chosen all the other nodes in the cluster to be data nodes and node managers and Flume Flume agents, means Flume client. It will facilitate us to run Flume jobs on all those things. And if you want to run Spark Thrift server on any of these things, you have to choose those things. So Spark Thrift server, I want to run only on the client, and I want to select all the servers as clients, so that if I want to submit the jobs and all those things, I can do that without any issues. Client will only make sure that configuration files are properly managed, so that we can run the jobs successfully from those nodes. Typically, we will not select all in the production. Whatever gateway nodes or clients that are designated as them, we only select those things. But here I am selecting everything. Okay. Now the slaves and clients are also configured. You don't need to worry much here. You just have to tell what all nodes I want to use workers, and you have to make sure that is reflected here, and then click on next. And then it takes you to the customized services. And as part of the customized services, it will prompt you to update certain important information. First, we'll start with Ambari metrics. Okay. Here it is asking for Grafana admin password. It is asking us to set the password because we are trying to set up for the first time. It is asking us to set up the password. You can give whatever password you want here. And then it will provide you a web interface later, and you can access that web interface using this username and password, which is admin, and whatever password we have given here. And then Hive. So whatever is red, you have to make the necessary modifications. Okay. And here you can go to advanced and it is asking to configure MySQL database. Now, by this time, you should be ready with the database. Again, in the formal process, you have to take care of this beforehand. You should not do at this time. You have to do it beforehand. As part of the MySQL installation itself, you need to take care of setting up Hive Metastore. Whether you want to separate it from the MySQL installation where you have set up Ambari server, or if you want to make it part of it, it's your choice. You can do either. Okay, now I'm going here. I'm coming back to HDP 00, and then I'm logging into MySQL. Show tables. So no database selected. Show databases, and hit enter. So there is a Metastore database here. I'm dropping that. Now I'm creating the new one. Create database Metastore. Drop user Hive. Now I'm creating new user. Create user Hive identified by IT Varsity. And then grant all on metastore.star to Hive plus privileges. Similarly, we need to create a database for Uzi also. It is not there here. So create database Uzi. Create user Uzi underscore user identified by IT Varsity. Grant all on Uzi.star to Uzi underscore user plus privileges. Okay. Okay. Now we have set up both the databases for Hive and Uzi. So here I am planning to use existing MySQL database, and it is asking to run this command called Ambari server setup. It is very important to do that. If you don't do that, it will not be able to connect to the database. We'll come back to that. Database name is Metastore. Hive is the username for which I want to use for Hive, and I have to give the password, which is IT Varsity. Okay, and you have to run this command. You just copy paste till here, and then you have to give the path of MySQL connector. In this case, if it is Oracle, you have to give the path to the Oracle connector. So user share Java MySQL connector java.jar and hit enter. If it is not available, you need to install that. You can use yum installer to install MySQL connector Java, and it will create a file over here in this location, and then you can set up the JDBC driver like this. If it does not work, then you can say find -name and give this jar file name. It will confirm whether you have the file or not. Okay. Now you can click on test connection. Test connection is okay. Now we have to go to Uzi. So first make all the mandatory changes, and this is not enough. You have to review certain important configurations, which I will explain once this is done. So here I am trying to use existing MySQL database. Uzi is the database name. Username is Uzi underscore user, and password IT Varsity in this case. and then click on test connection. Because we already ran Ambari server setup as part of Hive setup, it is successful. Now, this is not enough. We only changed the mandatory parameters, but you have to go to HDFS and make sure you are pointing to right directories for the name node, data node, etc. I will explain those things tomorrow. We will stop here. We will review these important parameters. Tomorrow we have to spend good amount of time, at least 20 minutes to half an hour, to understand how these memory settings and how we can connect our cluster to the storage. All those things I will explain, continuing the topic tomorrow in tomorrow's class, and then we will go to the next, which will let you review, and then it will install, start, dip, and test that your cluster is usable. This install is misleading. Installation is already done as part of no, installation is not done. In Cloudera, it will install first, and then it will ask for the configuration. Whereas in Ambari, it will first ask us to configure. It will install Ambari agent, but for the other components, it will first ask us to customize the services, and then it will install, and then deploy, and then it will run some unit test cases also to make sure that our cluster is configured properly. And we will continue understanding that as part of tomorrow's class. So that being said, before we wrap up, if you have any questions, I will take it, and then we will see tomorrow. Tomorrow, if required, we might extend a little bit. So be prepared, probably up to 2 hours. And tomorrow's class will be the last class. Sure, I will do that, Jiva. I will definitely glad to share my knowledge going forward, and you will be notified. What is Thrift Server for? So Thrift Server is for inter-language communication between two tools. So Hive is Hive and for example, Hive is primarily developed in Java. Okay, and if you want to use any Java-based language to issue Hive queries using JDBC, you can directly connect to Hive server and you can issue the queries. But if you want to use non-Java programming languages to connect to Hive, then Hive server will not work. You have to use Hive Thrift server. It has those capabilities of interlanguage communication while connecting from other programming languages than Java to connect to databases developed using technologies using Java. Example is Hive. Hive is developed using Java, and if you want to connect to Hive database using JDBC and programming languages such as JDBC or ODBC using programming languages such as Python, etc., you have to use Thrift server. Without Thrift server, it is not possible. Spark is also the same case. Spark is developed, I think, using Scala, and if you have to connect to Spark SQL, especially from a non-Scala based programming language, then you have to use Thrift server. Anything else? So meanwhile, there are a couple of relevant questions from Christian. He or she is asking, what do you think is better tool, Ambari or Cloudera Manager? It's a very good question. Both are equally good. Ambari is a completely free software, and it has earlier it was a little bit behind Cloudera, and there were some bugs because of the open source. The support is not very good, and it's cumbersome. But now they have improved quite a bit. I have reviewed the latest version. They are on par with Cloudera, and it is free. From the performance perspective, it doesn't matter. Ambari and Cloudera Manager are outside the Hadoop cluster. As long as your Hadoop cluster is performing good, these wrappers, even if they're a little bit slower, that is fine. So I give equally good rating for both Ambari and Cloudera Manager. And then Rohit mentioned, made a statement saying that we can get the repositories from the internet as well, right? I hope he might have got the answer already. Even though you can get the repositories from the internet, you have to set up the local repository. Otherwise, all the nodes will try to connect to the internet and download, and it can cause issues to the other services in the organization. So yeah, people use Python quite a bit to connect to Hive, and also thrift server comes handy for while you are using tools like Tableau, ClickView, etc. They might use completely different programming language, and they have to connect to the database to Hive or Spark SQL using ODBC or JDBC, and they also use thrift server. You don't use thrift server on regular basis, but any third party tool who want to use the Hadoop clusters for the reporting purposes, they might have a dependency on the thrift servers. So for that purpose, we will create thrift server so that any application can use it. And it's not heavy, it's very lightweight, and we will be having only on the client side. So even if it doesn't do much, it is fine. You can go ahead and set up the thrift server. So, and next question from Jiva is, could you say something about which source control is used in Hadoop framework? It depends upon the programming language. If it is Java or traditional programming language, people typically use SVN. That is the most famous source control used for any of the application development. And it is extensively used for Hadoop purposes also. But lately, people started using the public repositories such as GitHub. But in the enterprises, they still prefer SVN and CVS. Those two are the most prominent ones. So any other question? I can take a couple of more questions before we wrap up for today. Okay, I will give 10 more seconds. If you have any longer question, please convey that you are asking that question. Okay, then. Thank you very much. We will catch up tomorrow, and I will cover a lot of good information about how to plan the cluster based upon the memory requirements, or based upon the servers choice of the servers we made. How to plan for HDFS, how to plan for MapReduce, and Yarn, and also Spark. Those things will be covered as part of tomorrow's class. No. So there is one question from Mohsin, which is a relevant question. So I will answer that question. He is asking, when we download the repo in m.repo.d, that repo is local repo. No, that is not correct. m.repo.d, m.repos.d, that is the correct name. m.repos.d only have the configuration about your repository. It is not the repository itself. It only tell where your repositories are, whether they are in the public or local. If you have to set up local, you have to set up HTTP server. You have to download all the repositories, all the files that should be part of repositories, which are nothing but RPMs. And then you have to point your HTTP server to that location so that those repositories are accessible outside. Anyway, I cannot get into too many details here. If you are interested, I already demonstrated about how to set up the cluster and all those things in detail. You go to my YouTube channel. This is my channel homepage. In the channel homepage, you go to Hadoop administration and choose any of these URLs. For example, sorry, I accidentally clicked on that link. If you scroll down, here you can see how to set up Yum repositories. Okay, the best one will be the Cloudera version, which is this one. So it is more appropriate one. From Cloudera perspective, from Hortonworks perspective, you can go to the Hortonworks one. You can choose. I have videos for both. Okay. So you have to follow the steps to set up local M repository server. Okay, but to answer your question, m.repos.d will not have local repo. It will only have the configuration file pointing to the repository from where files needs to be downloaded. That repository can be a public repository or the local repository running on HTTP service. Okay. Okay, then. Thank you very much. I hope you are enjoying the session. If you like this video, if you are on YouTube Live, please click on the like button and share with your friends so that people get knowledge using these resources which are available for free. That being said, thank you. Bye.